Okay, so again, our situation is we have a rectangular path with a delta x, a delta y, C1, C2, C3, C4, it's a bad looking 3, it's even worse now. Okay, closed path, starting here, ending here. We want to do the integral of p dx plus q dy. Okay? So we could just say this, well, you know, just intuitively, if we have a sample point on C1, okay? So we're going to call this, okay, also let's just say that we've got this point here, and this point is x naught, y naught, okay? Just to give it specific coordinates. Okay, so now we have a point here, okay? So we're going to call this point, and I didn't leave myself a lot of room to label it. Well, we're going to take a point on each subinterval. Okay? So I'm just going to label them off to the side and say, okay, on the subintervals, got a point. I don't want to use P1 because I'm using P here, right? So I'll just label coordinates. They're sample points, so I'm going to use asterisks. I'm going to call this sample point x star. And what's the y coordinate going to be?
Why not?
Yep, very good. I was afraid you're going to say y star, which wouldn't have surprised me, but that doesn't surprise me. You answered it correctly. Because, yeah, when you see x star, you think y star. So, but you were thinking. It's catching on. I don't know what's happening to you. Okay, what are the coordinates of this point? Well, the y coordinate we don't know. It's a sample point along here, right? What's the x coordinate?
X naught plus delta x.
Very good. Okay, now I've got a problem, and I could do this without generality. I don't want to call this x star because this is x star and this doesn't have to be the same as this. Okay? So, it would be more convenient to use x star, but I'm not going to do it. I'll just use a tilde. It's a little more general, but it wouldn't hurt to have used x star up here. Because as delta x approaches 0, it really doesn't matter where you are, right? Okay, but over here then we're going to have
X naught.
y tilde star. Okay? That make sense? So, the integral over C1 of p dx is going to be approximately equal to, and I think I complicated things by using tildes. I might get rid of those. I think I overcomplicated it. It's not necessary. Then we could get around it, but it's going to add steps. So I'm going to get rid of the tildes, and I'm just going to put this point directly above this one, and this point directly across from this one. No more tildes. Okay, so integral of p dx over C1 is approximately equal to p of x star y naught times delta x. Right? Because it's a small interval, p isn't going to change much. So whatever p is at one point, it's very close to whatever p is, what p is at any other point. And so we're going to be taking a limit, and ultimately, as this thing shrinks to 0, that's valid. Okay? It's an approximation. It's going to get better and better as we shrink things down. Okay? And then the integral over C2 is approximately P of X star Y naught plus delta Y, right? Times what?
Delta Y. Or,
No, I'm sorry. I said C2, it's C3. Because I'm using the X star, it's up here.
okay, delta X.
Not quite. What's wrong with just using delta X? Which way is that thing going?
Oh, negative delta
Yeah.
X.
So it's negative this times delta X. Okay? So, integral over C1 and plus C3 of, I've got that P, that looks like a function, P of dx. I just want to write P dx. Okay, so it's getting ahead of myself. I started writing down the C1. Okay, sorry. Okay, so this is the integral over C1. It's dx. And now we use what we have here. So this is approximately equal to P of X star Y naught minus P of X star Y naught plus delta Y times delta X. Is that clear? I mean, this equals this equals this, but of course I factored out my delta X. We got the minus sign, of course. Okay? Well, okay, that's great. How is P of X star Y naught going to be compared with P of X star Y naught plus delta Y?
They're going to be approximately equal.
Yeah, but what's the difference going to be?
It's going to depend on dy.
Yeah, on the Y derivative. How? The differential. At least with respect to Y. Part of the differential depends on Y. Okay, well, it's this. You've got it. Okay? And I'm going to write it down because we're on short time today because of the weather. Okay? This is Py of X star okay, well, P of, sorry, doing two steps in my head at once, I shouldn't do that. Okay, for a lot of reasons. Okay, so P of X star Y naught plus delta Y is what? It's this. It's the value here plus the rate at which P changes with respect to Y as you go from here to here, multiplied by delta Y. In other words, this is the rate of change of the value of P with respect to Y, and you're multiplying it by the change in Y. Okay?
So it's your value plus your change in your value?
Again?
So it's your value plus your change in your value?
Yeah. Value here plus the change between here and here, which is due to the rate of change of P with respect to Y. Now that's not overly difficult. It'd be even less difficult if you really mastered differentials a year ago, but nobody ever does. I don't know why. Okay, I didn't either. I mean, I pretty much put them together when I needed them, and you're doing the same thing. I don't know why. I don't know. Don't know why that's except that nobody, in my course, nobody tried to teach anything intuitive. It was all formal. We were under the influence of the Bourbach key.
What's that?
Yeah, you don't want me to go into it, but look it up. A bunch of French formalists. We say you don't have to have any intuition, just do the symbols. And I mean, you know, I'm not denigrating it. It was kind of a neat idea, and there's still people that really like that. Okay, didn't fit me well, but it caused me to have to expand my brain a little bit to function in that environment. I was able to do it up to a point, and everybody comes to a point where they hit a wall, or whatever. Okay, so got this right. Well, doesn't that tell you then? Isn't it going to give you this? Because, of course, as a consequence of this, this minus this is going to be just a negative of this, right? And I didn't put the negative in. Okay? And right now, you've got an expression now in terms of the area of this region, which you ought to find astounding. If you have any emotions at all, you should be overwhelmed right now. I'm kind of borrowing that from Kahn, but I like Kahn a lot. Okay.
He likes being sarcastic.
Huh?
He likes being sarcastic a lot.
No, it's not sarcastic. He's being very, when he derives the Euler formula, e to the I pi, okay, equals -1. Cosine, sorry, it equals 1. It's cosine of pi plus I sine of pi. Okay? That's -1. I don't know why I said it was 1. He says, and if this doesn't blow your emotions, if this doesn't blow your mind, you have no emotions. One of my favorite things anybody's ever said. Okay?